This morning, I returned to the Shoop Site here in central Pennsylvania, and the Ohio University Archaeology Field School is just uphill from here, excavating one of the Paleo-Indian locations. Let's go see what they're finding.
You can almost like see how they would have thought to use this and how to haft it onto something.
Yes. I'm the main archaeologist at Ohio University, and we have a very active field program where I take students into the field quite frequently throughout the year, but our main training program is the Ohio University Field School. This field season, we are trying to assist in identifying these clusters and also help finish up the main block. I believe Kurt's been working on this 2, if not 3 years, working on excavating this main block with a small number of volunteers. A very great dedicated group of volunteers, but fortunately with the field school, we were able to put a lot more manpower in terms of getting these clusters looked at. It's been really interesting out here at Shoop because initially Kurt did a lot of very fine-grain testing every 5 meters across the site. And believe it or not, even at 5 meters, many of these clusters were missed originally. And so we came back and we started testing on this eastern side, and we started at 2.5 meter intervals, starting to get counts such as 34, 61, 61, 85, 16. And so if you look at these counts, they really mirror what is in the main block. And we're going to start doing the same thing on the western side of the site, where we had one with 6 that showed something different than the original transects across the site. And so by doing this very close interval testing at 2.5 meter intervals, we are finding clusters that were initially missed at the 5 meter interval. So what's going on here, Brian, is we had a positive STP with about 34 flakes in it. And this kind of rivals some of the counts that we saw in the main block. And so it looks like we have another cluster here that's similar, at least in density, to what we see in the main block. And we have also another one to the east. And so we're getting a couple samples in here for comparative purposes. It is hard to get perfect units when you have so many rocks out here. Yeah, we try to get the corners in with the total station at the exact northing and eastings, and then we have to lay in the units the best we can given all the rocks on the underground surface. So
Transit machine, and we placed on a known set of coordinates, and then based on the angle that we set and how far the laser travels, it can measure things out to about 1 millimeter of precision. So it's really nice when we're trying to correlate strata amongst units, because if you're just measuring everything with your line level, that's really prone to human error. People aren't holding the line right, if their datums are set at different heights, things like that. But with this, it's really easy because it's all based off of this area right here. So if we take a shot over there and it's reading 1.5 meters down in depth, and we take one over there and it's 1.5 meters down in depth, we know that that's kind of sitting on that same like horizontal strata. So it's really nice for a lot of the questions that we have here about how stratigraphy is laid down, the sedimentation of the area, as well as how flakes are moving through the different soil profiles.
this is completely flat, right? And so all that you need to do is measure different spots on the string line and then go down 10. Okay?
This string line theoretically represents the old ground surface. And so right now you're about 15, this floor is about 15 centimeters below the string everywhere. That was the goal. And that includes the A horizon, root mat, and then 10 centimeters to level 1. So you guys are working on level 2.
No. Genuinely very funny.
Digging around the stump, trying to get this whole area cleared out. I think we found a decent amount of flakes in this section. So these are like quad units. It's 25 centimeter intervals. So like 25, 25, and then we go in the 25 centimeter units to like get a good mapping out of where we're finding each artifact. So like we found 2 flakes in this subunit, and then we found 0 flakes in the subunit next to it. So that tells us really where the cluster is or where the flakes are being found at, rather than just it was found somewhere in this whole unit.
This is a great educational opportunity for these students. We're excavating in 25 centimeter units, which is very rare. I'm not sure how many other people have ever done that. The reason we're doing that, normally I come from the tradition, and Joe does too, of individually mapping every artifact to get to examine, so we can better examine or most effectively examine the human behavior and how that's reflected in these artifacts. Here the artifacts are very small, and we've tried it, it just isn't practical to try to map each one. 80% are less than a centimeter across. So it just to actually excavate those and map them individually would just be incredibly time consuming and also not very successful. We've tried it, but half of the artifacts end up in the screen. So trying to find them that way is just too difficult. Big tools and so on, yeah, that would be good, but we're doing the 25 centimeters. So this is a method that they aren't going to see very often.
Nope. Already got some.
Got a flake?
As the Paleo-Indians were making the stone tools, every time they hit, like little pieces would fly off. This one, I mean, I haven't been looking at these long enough to know, but the more experienced people can tell you like what kind of flake it is, like what they were doing when it came off. When we find a tool, it's like this is somebody's life, basically, that we're learning about. It's a really cool feeling.
This is actually bigger than most of the flakes I find. They're typically very, very small. So yeah.
How many have you found so far?
Like in total, there was an SDP that she and I dug. We had like over 60. But in this unit, we're in the double digits, but I don't think we're up to 20 yet in this unit. So they were all like a fraction of the size of this one. So you really have to look through the 1/8-inch screen and see if it's in there. Like I would find this in the 1/4 inch, but typically I can go a completely negative 1/4 inch screen, but then I will find like 5 in the 1/8-inch screen. So
it definitely pays to do the finer screen.
Definitely, yeah. So we focus a lot on that, but of course you're gonna pay a lot of attention to see if you have a big flake like this one in the 1/4 inch. So
Yeah, I took them.
So we try not to disturb the soil too much underneath the roots, just in case there's anything in place there that we want to keep the strata pretty even and natural as it occurs.
We just had to remove a large rock, so that's why I'm getting all this dirt that was under the rock and screening it separately.
When do you decide to take the rocks out?
Once they're mapped and photographed. Any rocks above 20 centimeters, we leave in and excavate around. Anything below that, we can just take out immediately. But we like to keep in the large ones just so we can, look at the spatial relationships between the large rocks. Measurements of the rocks are less important than the spatial relationships between them. So we just sort of estimate based on the subunit that they're in, the general shape, and position.
I'm mapping out where these 2 big rocks are that we didn't remove, and then the root. But it's taking a bit of time because the map sheet is in 5x5 grid, but we lay out the pins in
4x4, 25 by 25 for each one, but these squares are in inches, and these are in centimeters, and it's also a different number, so
yeah,
it's a bit of translation.
I'm currently going through all the old STP paperwork and trying to organize it east to west. So we have the coordinates, the northing and the easting, and so I'm starting at the lowest easting number and moving up to the highest easting number. So right now it's 184.5 and the highest is 212.
Joe put another shovel test pit another 5 meters over here and didn't find a whole lot of flakes. I think 6 flakes came out of that unit, but he did find a tool that we call a limace. It's a long piece, so yeah, it's a long flake. It's heavily worked on both sides. It's a uniface. It's heavily worked on both sides, and frequently it is pointed at this end. We're really not sure how or what these were used for, but we'll again do microwear analysis of this, or we'll contract for microwear analysis for this. This is kind of fun. It's got the striking platform on it. It came off a relatively steep angled core. And it's also thermally altered. The pointed end, theoretically, was thermally altered, and there are pot marks on here, so this has been damaged. This is not the way it looked when it was actually being used, or at least when it was first knocked off the core, because there's 2 big pot marks from heat. But also it does seem you have very consistent flakes along steep, retouching along this edge and along this edge, and they're relatively close together. But here and here, large flakes were taken out, and possibly this was for hafting. So possibly it was hafted like this in a piece of bone or antler. And sometimes these have been characterized as they've been called flake shavers, for shaving wood or some hard, bone or antler, but we won't really know until we do microwear on the edges. It's a really extraordinary piece. It was found 22 centimeters below the surface in that BE horizon. It was laying flat and actually was stuck in the wall. Carly actually found it.
So I found this in this STP dug right over here. We were digging down and I was cleaning our floor just to get a level of the depth, and I was sweeping it off, and there's about like this much that I see. And like even if I just seen that much, I'd know it was really something special. But I immediately I just go, hey Joe, I think I need your help with something. And I come over and he sees it sticking out. He goes, Carly. And so we take it out, we're looking at it, and it's 9.9 centimeters, I believe, which beats out a lot of the other limace stone tools in the area, and the fact that it's jasper makes it really cool for this area, given that the vast majority of the chert and raw material used at the Shoop in this site is Onondaga. And it was also really cool to see this end here with that color change to it, because that's really indicative of some heat treatment, whether it was on purpose or an accident. We can't entirely say yet, but I think a really cool next step would be digging out in this area a little more to see what else we can find. But it was really cool to find. I'm glad I didn't drive a shovel through it. But yeah.
What's it feel like to handle something that no one's touched for 13,000 years?
It's a really cool experience to be able to do that, especially because I before coming here I have taken a lithics class, and I've done a little bit of stone tool making myself. I'm not good at by any means, but I do know what they were thinking as they drove off this flake, and then they took off these additional bits to kind of form this edge here. And you know, like, I mean, it's not for certain, but like, you can almost like see how they would have thought to use this and how to haft it onto something just with the way they ended up shaping it. So it's really cool to like see into the minds of someone that you never know and you will never ever know, but you can get an insight into what was important to them and what they plan to do.
Steve is been flint knapping for, I've known for 30 years. He's gotten very, very good at it. And he makes fluted points on a regular basis. This is Onondaga chert again. The fluted points here are all Onondaga chert. And this is pretty typical of the fluted points from the Shoop Site. It's a little wider, but it's a Clovis-like. The only reason that this isn't sort of technically a Clovis point is that it has a indented base. It's more indented than usual, and this would fit that definition. The ones at Shoop, when we measured them all, Joe Gingrich and I measured. So I think we have 72 that we had access to. There's 100. There's more than 100 that have been recorded from the site, but we measured 72, and on average, yeah, the base is more indented than from Clovis sites out west, for example. Mm-hmm. But yeah, this is pretty typical. Short flute, parallel side, with relatively short ears. That's what we got from Shoop. So we think it's slightly later, but he's really a master. He made these though, and they're hafted. This is an elk antler. He split the antler here, so the end scraper probably extends back to here. Then he glued it in place with pine tar, then wrapped it with actually wet hide. When the hide shrank, it squeezed this actually so tight that the pine tar started to come out. And so far the end scrapers that we've tested with microwear are looking for microwear. They're all hide scrapers. And this is more typical of what I've seen Inuit hafted end scrapers for scraping hides. And this is the handle that I remember. And again, it was split so they could lay the end scraper in here, and again with pine tar and hide.
Thousands of artifacts have been found here. Most of these artifacts are less than a half centimeter in size, and this is what we would expect because all of the chert that these people are using, all of the tool stone that people are using is from a very long distance, and so most of what's going on here is resharpening tools, recycling tools, making a few tools, but we're seeing the final stages of production and oftentimes the very last attempts to resharpen something before it is discarded. About 98% of all the raw material is made of Onondaga chert, and so it looks like one of those events that people geared up with all their tools to move south. So maybe this was a winter encampment, but we see this pretty consistently in the Paleo-Indian record, that we have many sites where it's 200 kilometers away from the source. But Shoop was one of the first documented sites in eastern North America to show this in terms of this long distance movement of a single stone with a hunter-gatherer group.
Well, mainly what it means for this project is we're getting a lot more work done. We depend on volunteers to work here, and that's what we see with the field school kids. Beyond that is, I mean, we've gotten immense amount of work done in 2, 3, 4 weeks that would take us all summer. You can see these broad areas that have been taken down 2 levels since they got here, and they'll get down at least 2 more probably over the entire block. And therefore, we're going to get a better picture, image, if you will, of the distribution of artifacts. And we're going to get that distribution, down 4 levels. So that's going to be very useful information, understanding what kinds of activities actually took place here.
And the Ohio University Field School, we are on almost our 40th year that we have run consistently, and we are the oldest continuously operating program in the state of Ohio right now, with getting students to the field, if not every year, every other year. But we always have a large excavation component, and so in recent years we have been looking at several Paleo-Indian sites either in Ohio or this year in Pennsylvania. A large portion of our students do go into cultural resource management, but in recent years we have had probably about a fourth of our students go into other graduate programs, and fortunately a lot of these students have been fully funded in these graduate programs. These are our best students that not only take the Archaeological Field School, but they often do a federal internship, and then by the time they are done, they have lots of field experience and have been very competitive getting into graduate programs.